Hello everyone, welcome to my channel, The Big Boolean Theory. This video is part of a lecture series on operating systems, and currently we are on the first module of this course, that is the introduction module. And the idea behind this module is to give you a basic introduction to operating systems. So within this first module, we are currently on our first topic, that is computer hardware review, right? And in this topic, we are going over the computer hardware concepts one by one. So a few videos back, we talked about the CPU. Then in the previous video, we looked at the memory. Now in this video, we are going to talk about the input and output devices or IO devices. So we are going to understand what is their role in the computer system, how are these IO devices structured, how do they function, and finally, what is the interface that the IO devices exposes to the operating system. So without further ado, let's get started and study about IO devices in more detail. So let us start the discussion with this basic model of a computer. We have already seen this model several times, but let's recall this model once again. So basically, this model of a computer is depicting what are the major components, major hardware components in the computer system, and how are they organized. So as you can see, there are three major components. The first is the CPU, then there is the memory, and then we have a set of IO devices. And all of these components are connected by the bus, right? So in the previous videos, we have talked about the CPU and the memory. And in this video, we want to study about the IO devices in more detail. So now let's understand what is the responsibility or the role that the IO devices play in the computer system. So in order to understand what is the role of the input and output devices, let us revisit this von Neumann model that depicts how the computer system works. So if you see this model, the computing starts, the process or the user journey of computing starts with the input devices. So as a user, we are using the computer because we want some of our input data to be processed by the computer in some way, and that after processing we want some kind of output. So there is some input that the user wants to give, and it wants the computer to process it in some way, in meaningful way, and give it some kind of output, right? So this is how the flow of the computing goes, and here the input basically comes from the input devices. So there are a lot of input devices, using all of which the user can give their input, and this input could be in a wide variety of formats. For example, it could be textual input, it could be an image, audio, video. So there are a wide variety of information formats that are available out today. So point is, the user will give some kind of input via these input devices, and finally the computer system will process this data. So the input that is received from the input devices goes into the memory, and then the processor processes that data, and finally when some output data has been generated, it is sent to the output devices for the consumption of the user. So the role of the input devices is to receive input from the user, and finally the output devices are there because from there the user can consume the generated output. So now let us look at some examples of input and output devices in the computer system. So this slide gives some of the examples of basic input and output devices. So let us go over them one by one and discuss what is their functionality. So the first basic input device that we have is the keyboard. So we use keyboard to type in characters, and these characters come as textual input for the computer, and sometimes some combinations of characters are also used to control the behavior of the computer system. So this was the keyboard. The basic input format in the keyboard is characters. Then apart from the keyboard, we have the mouse. So the mouse is a pointing device, and we use it to point to different locations on the screen or to select some objects. So the basic input that comes from the mouse is some kind of position, right? So when we are pointing to a particular location, so the basic input that comes from the mouse is a positional information. And apart from that, not just the position, there is some buttons that we also click. So there are two buttons, left and right. Depending on that, certain actions are taken. So apart from the positional input, the buttons also play an important role. So that is another kind of input that the mouse provides. So this was about some of the basic types of input devices in the computer system. So now let's talk about the output devices. So the most basic example of an output device is the monitor. So the monitor is a screen on which a lot of things are displayed, and whenever there is a user who is interacting with the computer system, then there is a requirement for a monitor. And by looking at the monitor, you can get an idea of what is running in the computer system, and also whatever output results that are produced by the computer applications, that is also displayed on the screen. So it's like a view of the computer system for the user. So this was about the monitor. And then let's talk about the next output device, that is the printer. So we often use the computer to make digital documents, and when we want those documents physically with us, then we can print those documents. That is where the printer helps us out. So it takes a digital document and prints it on a set of paper, right? So this was about the printer, and some of the basic examples of input and output devices we have now seen. So till now we have seen examples of devices that are either purely input devices, for example, the keyboard and the mouse, or the devices are purely output devices, for example, the monitor and the printer. But there also exists certain devices which can act both as input as well as output devices. So this slide gives you some of the examples. So let's take the example of the hard disk. So when you're reading from the hard disk, when you're reading data, at that time it is acting as an input device for the computer system. And when you're writing some data to the disk, and in that moment it is acting as an output device for the computer system, right? So you can both read and write from the disk. So that disk can act as both input as well as output device, right? Compare this with either the keyboard or the mouse. These are purely input, or the monitor and printer, these are purely output. But these devices can act both as input as well as output devices. So the USB stick or the pen drive is very similar to the hard disk, right? Then there is this internet. So the network adapter, your network adapter can both receive data packets or send data packets. So as you can see, when you're receiving data packets, then it is an input to the computer. When you're sending data packets, it's an output, right? And finally, this headset, if you see this, when you're speaking, when you're giving audio input, it's an input device. But when you're listening, at that moment, it becomes an output device. So these are some of the examples of IO devices. Some are purely input devices, some are purely output, and some can act both as input and output depending on the use case. So these are some of the examples of IO devices. Now let's understand how the IO devices work. So now let us try and understand how does these IO devices work, right? So this is the computer system, and you can see we have a set of IO devices. So the first major point that we need to understand is that every IO device has two parts, right? The IO device, first of all, has the device itself, and then associated with the device, there is a device controller. And the fundamental responsibility of this device controller is, as the name suggests, it has to control the device. So let us understand how does this device controller look like. So first of all, till now we have shown the picture something like this. So in this system, there are n IO devices, right? So the point is that this single block is actually two parts. So the updated diagram looks something like this. So if you talk about the keyboard, then there are two parts. First of all, there is the keyboard itself, and then there is the associated keyboard controller that is responsible for controlling the keyboard. Similarly, for the display, we have the display controller, and for the disk, we have the disk controller. So this is how the first major part that you need to understand when you're trying to understand how the IO devices work is that there are two parts. First is the device itself, and then associated with the device, you have a special chip. It's an electronic chip that is called the device controller, and its fundamental responsibility is to control the IO device that it is associated with. So before we proceed to talk about the device controllers, let us first of all modify the compute stack a bit, because this will be essential when we talk about the device controllers. So this is the compute stack, and you have already seen this in the earlier videos also. So this is a view of the computer system, where we say that the computer system is organized as a set of multiple layers. At the very bottom, you have the hardware layer. Then there is this hardware interface, and on top of hardware, there are several layers of software, right? So as you can see, first of all, there is the operating system, and on top of the operating system runs the user applications. So now we are talking about IO devices. So let's focus on the hardware layer. So as we just said that the IO devices have two parts, that is the device itself and the device controller. So this hardware needs to be modified accordingly. So as you can see, there are two parts, the device and the device controller. So now accordingly, we have two different interfaces. One, that is the device interface exposed by the device itself. And then there is this device controller interface associated with the device controller for the device. So if you see this diagram, updated diagram, there is an interesting point to notice that the operating system is not directly interacting with the device. So these are the IO devices. The operating system, the layer of software, the bottommost layer of software that is running, is not directly interacting with the device. It is interacting with them via the device controllers, right? So you can see the operating system is interacting with the device controller interface, so it never gets to interact with the device interface. So this is how the updated compute stack looks like. So now we can talk about how the device controllers work. So now let us understand what is the device controller and talk about it in more detail. So let's zoom into one of these devices. Let's take the example of disk controller, and here you can see this diagram, right? So the first point is that we already know the device controller is a piece of electronic chip that has been designed to control or manage the device that it is associated with. So first of all, if you see this diagram, there are two parts. There is the hard disk and then there is the disk controller. So if you talk about the hard disk, it's a mechanical device. If you see it's working, then there are several disk platters that are mounted on a motor, and the motor rotates these disk platters at high speed, and then there is a disk arm that moves over this disk platters to read the data. So as you can see, there is a lot of mechanical movement that is going on. So that is why the hard disk is a mechanical device. But if you contrast this with the associated disk controller, the disk controller is a silicon chip. It's an electronic chip. It's not a mechanical device, right? There are no moving parts, and it is like the CPU, but the difference is that the CPU is a general purpose chip, right? It can run any program. It has been designed for a generic use, right? However, the disk controller, it's a special purpose chip that has been designed to do one specific thing, that is to control or manage the hard disk. In the same way, so the device controller is a special purpose chip that has a very specific purpose of controlling the associated device. So this was the basic point about the device controller. So let us see some more points to understand the device controller in more detail. So the next point is that the device controller receives commands from the operating system and carries it out on the device. So we saw the updated compute stack where we said that the operating system does not directly interact with the device. That means that the operating system will not be directly communicating with the hard disk. Instead, it will be interacting with the device controller, that is the disk controller in this case. So any command, for example, reading or writing data on the disk, whatever command that the operating system wants to carry out, it has to give it to the device controller. And now the device controller has the responsibility to carry out whatever command has been given by the operating system. So as you can see, the command is received by the device controller and then it accordingly drives the device. So the next point is that all device controllers have a local buffer or small piece of storage on the chip, and their basic job is to move data between this local buffer and the device. So basically in the previous slide, what did we say? We said that the operating system gives some commands to the device controller to carry it out on the device. And what would be these commands? Since it's a device controller, then the commands that it will receive either will be either to read some data from the device or write some data to the device, right? So in that reading and writing, this local buffer plays an important role. So let's say there is an input device that is keyboard, and the operating system wants to read the data that the user is typing. So in that case, what will happen is that whatever data that or the characters that the user is typing, the keyboard controller will read that into its local buffer, and then operating system can read those characters from this local buffers, right? So you can see when it's an input device, the device controller is transferring data or moving data from the device to its local buffer. Similarly, if it's an output device, for example, let's say the monitor or the display, right? In that case, when the operating system wants to display some bytes on the screen, then it will write that data into the local buffer, and then the display controller will move that data or copy that data to the device so that it is displayed on the screen. So this is how moving the data between the local buffer and the device falls under one of the most basic responsibilities of the device controller. So the next point is that the device controller is also responsible for monitoring the status of the device. So before initiating any operation, the device controller has to ensure whether the device is busy or not, right? It could be possible that the device is already busy with some previous operation. that operating system might have requested, right? So before initiating any new operation, the device controller will first of all monitor the status. Only when it is idle, then it can initiate a new operation. Also, when the operation is completed, then it could either be successful or it could be an error. That status information also has to be monitored by the device controller so that the operating system can get that info. So the next point is a very important one. It says that the interface that is exposed by the device controller is much more simpler than the actual device interface. So if you recall the compute stack, there we said that the hardware can be split into two layers. The first is the device, and then there is the device controller. And accordingly, we had two different interfaces. So the point is that the device controller interface is much more simpler. So let us understand this point with the example. Let's take the example of the hard disk. So the hard disk is a storage device where we store our data, right? As a programmer, we are concerned with our data and reading and writing them. But if you compare the two interfaces, the one that the hard disk directly exposes with the one the disk controller interface exposes, there is a lot of disparity in how we think about the hard disk. So let's first talk about the disk interface. This interface is very low level and specific to how the disk has been implemented, right? If you have to read or write data at this level, then you have to talk in terms of how much the motor should rotate, at what speed should it rotate, how much should the disk arm move over the disk. So these are very low level details of how the disk works, which we should not be concerned with, right? We are concerned with storing our data and not how the disk operates. That is the domain of the hardware engineers. So this interface is non-intuitive and complex. So let's now compare this with the disk controller's interface. So what the disk controller interface exposes is that the disk is a storage, and it is a sequence of blocks. Each block has an address, and in order to read a block, you have to just give the address. In order to write a block, give your data along with the address, just like how the memory works, right? So this view is much more closer and to how we think, and very simple to use. Compare this with the actual disk interface. So this is how the device controller first of all abstracts out the mechanics of how the device works, right, and makes it very simple to deal with the device. So let's now take one more example to understand this point. Let's talk about the display. So as you can see, again we have two different interfaces. One is the display controller interface, and the one is the actual hardware display interface, right? So the basic responsibility of the monitor or the display is to output the screen. So there is a sequence of frames that we render on the screen. So as you can see, the first interface, the display controller's interface, is just asking for the frame or the bytes that you want to display. Here we are thinking in terms of the data that we want to display. So this is very close to how the programmer thinks. Then what the display controller will do, it will convert this high level commands into the low level specifics on how the display is actually working. What should be the color for each pixel, what should be the voltage, right? Here the display controller is dealing with the specifics of the display. Now as a programmer, we don't have to care or deal with this low level interface. So you see how the controller first of all simplifies the interface, abstracts out the complexity, and relieves the programmer from dealing with the actual low level interface of the device. So this is one of the major advantages of the device controller, that it presents a much simpler interface than the actual device interface. So now we have understood what is the device controller and how does it function. So if you notice, there are two connections associated with the device controller. So one is called the device port, where the device connects with the controller, and the other is called device controller interface, which is where the bus connects with the device controller. So let us now talk about these two connections in more detail. So let us understand about the two connections that we talked about with this example. So here we have the keyboard, and associated with the keyboard we have the keyboard controller. So this gray region, the shaded part, is basically meant to show that this part is inside the computer system, right? And this is the periphery of the computer hardware. And at the periphery, you can see there is a connection where the keyboard will connect with the keyboard controller. Basically, this is the connection where the keyboard, the wire coming out from the keyboard, that is this USB cable, will be plugged in. And this connection is called the device port. These connections, we are all familiar with these connections. Whenever there is a wire leading from a IO device, that we can plug into the periphery of the computer hardware into the appropriate slots. So that slot or connection, you can say, is the device port, right? And now let's look into the internal of the computer hardware. So this is the region that is hidden from you, and you can view this when you open up the computer system. So hidden from you is the other connection where the controller is connected with the bus, and that connection is called the device controller interface. So this is the connection with which the software communicates with the hardware, and all commands from the operating system will be coming to this device controller interface via the bus. So let us now look at how the controller actually looks like. So here I have taken two examples. The first one is the Ethernet controller, and the second one is the USB controller. So as you can see, the Ethernet controller, which controls your network communications, this is the Ethernet controller, and here we have the device port. So in this context, this is the Ethernet port where the LAN cable is inserted, right? So you can understand the two connections. The first one is where the wire will be plugged in, the device will be connected. In our case, this is a LAN cable. And the second connection is where the controller will be connected with the bus. So this is the Ethernet controller interface, right? And it has been named as PCIe interface because after the naming of the bus that it will be connected to is called the PCI interface. That is why it is also called the PCIe interface. But basically this is the device controller interface for the Ethernet, right? Similar to the Ethernet controller, you can see here we have the USB controller, and here instead of having one device port, there are 4 device ports. So sometimes a single controller can handle multiple devices. So this is another major point. So this USB controller, you can connect 4 USB devices into this controller, right? And it will be able to manage all those 4 devices. And the other connection, this you can see, this is the connection which will go into the bus. So this is the device controller interface for this USB controller. So now you can see how the controllers look like in real life. So in the previous slide, we saw how the device controllers look like, but that is not the only way in which the device controllers are manufactured. So basically there are two different ways in which the device controllers are available in the market. The first one is called the printed circuit card. And the example that we saw in the previous slide is the example of printed circuit card. So here basically we have a card on which the circuit has been printed, and this card is basically an isolated chip that can be inserted into the bus. So in this example, there is the PCIe Express bus, and it has some expansion slots into which you can insert this part, that is the device controller interface part, and that is how the device controller will be connected with the motherboard, right? The bus is on the motherboard, and there are slots into which you can insert these isolated circuit cards. So this is one way that we just saw in the previous slide. The other way is that instead of having them as separate cards, the device controllers are manufactured as part of the motherboard itself. So when the motherboard is being printed, the device controller is made a part of the motherboard. And as you can see here, there are an array of device ports, and all these device ports will have their associated device controller interface, not the interface, the circuit printed as part of the motherboard itself, right? So you can see here you have the HDMI port, and then the LAN port, the audio jacks. So these ports will have their associated controller circuits already printed as part of the motherboard, right? And this is another view of the same motherboard. So these are the two ways in which the device controllers come into the market. Either there are printed circuit cards that you can insert into the bus slots, or they are printed as part of the motherboard itself at the time of manufacturing. So now we have understood about the device port. So we are done with one of the connections that is there on the device controller. Let us now focus on the other connection, that is the device controller interface. This is the part where the device controller is connected with the bus. So let us recall this compute stack diagram and understand about the device controller interface. So as you can see at the very bottom, we have the IO device, and on top of the IO device, there is the device controller that is responsible for controlling the device. And the operating system will not be communicating with the device directly. All communications will happen via the device controller. So let us now see the interfaces. So this one is the actual hardware device interface, right? And this one is the device controllers interface, which is much simpler than the actual device interface. So this actual interface, we have already seen two examples of hard disk and display, how this interface basically deals with very low level details and how the device has actually been implemented. So this one is a complex interface as compared with the device controller interface. This is a simpler interface which is much closer to how the programmer perceives the device, and this is the interface with which the operating system communicates and gives all the commands to the device controller. So let us now see how the operating system communicates with the device controller interface and gives the commands. So let us understand how does the operating system use this device controller interface to communicate with the device controller. So the basic idea is that there are a set of registers in this device controller interface which the operating system can read or write to give any command or perform any kind of communication with the device controller. So let us take an example and see how these registers could look like and how does the operating system use them to communicate. So for that, I have taken a real disk controller interface. So let us go over the registers one by one and see what are their functionalities in this particular disk controller interface. So let us zoom this picture a bit. So as you can see, this is an example disk controller interface and it has roughly 8 to 10 registers. So let us start with some of the registers. First of all, the important one is the status registers. So it is at 1F7. So this is a status register, and basically, as you can see, it is a set of flags, and every flag says what is the status of the device. So for example, the most significant bit tells whether the device is currently busy or not. If it is busy, then it is performing some operation. It has already started, right? At this moment, you cannot give any new command to the device. Next, let us look at bit number 6. So if this flag is set, which means that the device is ready. So this is the status that we are interested in. When the device is ready, then the operating system can give a new command. And similarly, there are several other status flags, right? Another important status flag which is interesting is the error flag, error status. So we'll look at this in a while. But after you have given the command, let's now look how we can give the command to this device. So basically there are a sequence of registers from 0 to 7. So you can see how the operating system uses these set of registers to give the command to the device controller. So here there are some registers which are where the operating system will give the low address, middle address, or high address. So these are the range of addresses where the operating system wants to read from the device. Then sector count says how much, what is the size of data that the read or write has to happen, right? So as you can see, there are several registers that are associated with giving the command. And when the operation is completed, then there could be either a success or an error. So when there is an error, then the status, the lowest significant bit of the status will be set. And then if you see, there is a error register. Just like there is a status register, there is a command register, there is an error register. So the error register is at 1F1, and it basically also has a set of flags. And each of these flag, when it is set, can signal a different kind of error. So there are different types of error. For example, command has been aborted, or address has not been found, track has not been found, right? So these are the flags that signify some kind of error has occurred. And finally, there is some control register also, which controls the behavior of the overall device. So you see how there are different types of registers in this disk controller interface, which allow the operating system to read the status of the device, give commands to it, and after the operation is completed, check whether an error has occurred. And not only that, via the control register, the operating system can control the behavior of the device also. So this is an example of the device controller interface, and you see how using this set of registers, the operating system can communicate with the device. So now we have understood how the operating system communicates with the device controller via the device controller interface. So if you look from the operating system's perspective, first of all, this is the device, right? It is not interfacing with the device directly. There is a device controller with which it is interacting. And within the device controller, there is a set of registers that is called the device controller interface. So from the operating system's perspective, an IO device is a set of registers because that is what is visible to the operating system. So this is how the operating system perceives an IO device. It's a set of registers in the device controller interface, right? So that is the hardware interface that is exposed by the IO devices to the operating system. So now we have looked at the different components in the IO devices. First of all, there is the device itself, then there is the device controller. There are these connections also, that is the device port and the device controller interface. And we have also seen how the operating system interfaces with the device controller using the device controller interface. So now let us bring all of these concepts together and see the bigger picture. That is, let us take a example operation and see how is it carried out end to end. So this is the same example, the disk and the disk controller. And here we have the disk controller interface. So the first step before starting any operation is to check whether the device is ready to take commands or not. If the device is already busy with some operation, then the operating system must wait. So there is the status register, which we already saw. So the operating system reads the status register first of all and checks if it is busy or idle. If it is busy, then it will wait. If it is idle, then it will give some command, right? And there are some command registers into which the operating system can properly write the command. So let's say there is a read operation that has to be performed from the disk. Some data has to be fetched from the disk, let's say. So the operating system will write the appropriate command in the command registers from where the data has to be read, how much data has to be read, and all those. So once the command has been given in the device controller interface, then the device controller can begin the operation. So once the device controller has received the command, then it can begin operation on the device. So first of all, the command that has been received is at a higher level than the actual disk interface, right? We have already seen this. That is, the device interface is much more complex and low level than the device controller's interface. So the command has been given to read some data from some addresses. First of all, the disk controller will convert it into low level commands. For example, the disk is a mechanical device. It has to it understands movements in the form of motor rotations and arm movements. So first of all, the disk controller will convert that high level command into low level commands. That is, it will ask how much the motor has to be rotated, how much the disk arm has to be moved, right? In this way, first of all, the disk controller converts those commands into low level device specific commands, right? Then after the commands has been given, the actual read operation will happen and the data will be read from the disk into the local storage, right? So this movement of data between the device and the local storage has been done. Then what the controller does, it does some final post processing, right? The data has to be assembled. If there is some error in reading the data, that has to be handled. After all the post processing has been done, then the data is ready and can be handed over to the operating system. So now that the operation has been complete, then the disk controller can notify the operating system that the operation has completed and the status of the operation will be available in the status register. If the operation is successful, then the operating system can read the data from the local storage, right? And if there has been any failure, then the exact reason of the failure will also be available in one of the error register. Then the operating system can take any appropriate action to handle this situation. So this figure, this compute stack summarizes the flow of operation in case of an IO device. So the requests come from the user applications, right? It could be to read some data or to write some data, whatever is the case. An IO request begins from the user application. Then the operating system takes that request and gives some commands to the device controller via the device controller interface. Whatever commands are received by the device controller, it converts into low level device level commands, that is at the device interface level, and are very specific to the internals of the device. Then that operation is carried out by the device. It could be an input or an output operation. And when the operation is completed, then the device controller notifies the operating system. If the operation was successful, then the operating system takes the results, or if any error has occurred, then in that case the operating system will take appropriate action, and finally the results are returned to the user application. So this is how the flow first goes down the stack, and then after completion of the operation, the results are transferred upwards. So this is how the IO operation happens overall, right? So this gives you a complete end-to-end picture. So guys, this was it for this video. In this video, we talked about the role of IO devices. We discussed several examples. Then we understood what are the different components. That is, there is a device, there is a device controller. Then we talked about what is the controller and what are the connections that it has, device port, device controller interface. And then we saw how an IO operation takes place. So guys, this was it for this video. in this video, I hope you understood how the IO devices work. So thank you very much for watching this video, and I'll see you in the next video. Thank you.